All right, good morning, everybody. I hope you all had a safe and fun Halloween. I certainly did with my little guy. We dressed up as Oscar the Grouch and Cookie Monster. We had a great time. So it was a perfect night. So let's get started. We talked about last week finding the area of triangles, and we did that using first reasoning. Um, on how we found the area of parallelograms, and then from that how we could find the area of the triangle. But then later we used a nice simple formula that made it a lot easier to find the area of the triangle instead of having to do all that work. So today we're going to talk a little bit about that a little more, except instead of finding the area, we're just going to talk about finding the base and the heights of triangles. So on this example here, we're going to draw on the grid a triangle with an area of 12 square units. So how do we do that? We're going to draw two. We're going to draw one right triangle, which means that one of the angles is a 90-degree angle in the triangle. And then we're going to draw another triangle that's not a right triangle. So let's look at this. This nice grid here makes it super simple to draw. So the first triangle we're going to draw with an area of 12 square units is a right triangle. So how do we find, well, first let's see, how do we find the area of a triangle? Well, we use our nice formula that was base times height divided by 2. All right, so let's move this guy out of the way. All right, so in this case, we want our area to be 12 square units. So if you recall, when we found the area of a parallelogram, like we've mentioned, we did that by using the formula base times height. And to find the area of a triangle associated with that parallelogram, we just divided that by 2. So if we need 12 square units for the area of our triangle, what do you think the area of a parallelogram would be that we made from our original triangle and then a copy of that triangle? Well, it would be twice that, or 12 times 2, which would be 24 square units. So we need to draw a triangle with a base of something that will multiply times the height to give us 24 square units. And then we'll divide that by 2 to get to the 12. So let's do an example. So if we want a triangle, say with a base of 8 units, and then what do we need to make that an area of 24? Well, what is 24 divided by 8? Well, that would be 3. So we need a height of 3 square units. So here at the bottom, we use our base. B is equal to 8. And then that gives us a height equal to 3. So if we plug those numbers into our formula here, that gives us base of 8 times our height of 3 divided by 2 is equal to 12. So if we were to, again, make a copy of the triangle, that would give us the parallelogram that you see there. And we know that the area of that parallelogram would be base times height, or 8 times 3. That's equal to 24. But if we take half of that, to find the area of the triangle, we know we get this, we use this formula down here, and we get 12 square units. All right, so let's try one more, and we're going to draw a triangle that does not have a right angle in it. So again, what is our formula for the area of a triangle? It is base times height divided by 2. Put that up there. And again, we know we need our triangle to be 12 square units. So again, we need, if we were to make a parallelogram out of our triangle that we want, we know we need the area of that to be twice as much, so it would be 24 square units. So let's see how we do that. All right, let's draw, we want our base in this case to be 6 units, okay? So if we have 6 units for our base, we know what? That our height needs to be 4 units. So let's draw that here, and then I will show you how we got that. But we know 6 times what is 24? 4. So that's how we knew we needed to use the height of 4. So our height would be there. And I'll remind you here in just a second how we find the height, but I want you to see how we draw a triangle to get a 12 square unit area. So our base is equal to 6. We chose that there. And our height is equal to 4. So how do we get our area? We use this formula up here, which gives us 6 times 4 divided by 2, and that is equal to 12. So if we were to make a parallelogram out of this, we would just make an exact copy of the triangle. So what would the area of this parallelogram be? Well, we know it's base times height, so it would be 6 times 4. That'll give us 24. Now, how do we find the area of a triangle that we used? We divide that by 2. So 6 times 4 equals 24. 24 divided by 2 is equal to 12. All right, so let's go back to our slide presentation. Now I'm going to show you 3 copies of the same triangle. So each of the copies of this triangle, it's the exact same triangle. We're going to, it's been rotated, so the side that we're choosing as the base is at the bottom or horizontal. So at the bottom or horizontal, the side would be here. So our base in this case is going to be the side A. So what we're going to do, we're going to draw a height of our triangle that corresponds to that base. Now we're not going to be able to use an index card like the question says because it's on the computer. But if we're ever writing it out on paper, I'll show you a little example of how to use an index card, and it makes it nice and neat so we can draw a straight line. But if we're using our base A, how do we find our height? Well, we have to draw a perpendicular line to the opposite vertex. Remember, our vertex is just the corner of the triangle, or where two line segments meet to create an angle. And if you recall, I mentioned last week, when we're drawing our height, it's always best if you can to draw it to the opposite vertex. So in that case, it would be like this. Because our line can only go as far as the opposite vertex, so that gives us our height. So our height would be here. Sometimes, if you remember, I mentioned that you won't be able to draw it out inside the triangle because the vertex doesn't fall directly above the base, and I'll show you an example of that also. So let's go to our next triangle. So here, our base is going to be B. So that makes our opposite vertex, or the opposite corner, right here. So remember what I just said about sometimes the vertex not falling directly above the base? Well, this is one of those examples. So if we were to draw, and again, let me back up for just a second. When we're drawing a perpendicular line from the base, I would always encourage you to start at the opposite corner or the opposite vertex and draw a line to the base. So like I just mentioned, this vertex just happens to fall outside of the triangle to the base. So how do we work that? Well, in this case, we can draw an imaginary line to extend the base out to meet the line from our vertex. So this would give us our height, this blue line. So again, we're still drawing a perpendicular line from the base to the opposite vertex to give us our height, but sometimes we have to draw that line outside of the rectangle, or excuse me, outside of the triangle like we did here. So let's look at one more. All right, so here's another one. We've got our base C down here. All right, let me start over. It's not a very good drawing. All right, I'm gonna have to erase it. Okay, let's try that again. So we're starting with base C. So that makes our opposite vertex, our opposite corner right here. So does that look like we're going to be able to draw a line inside the triangle, a perpendicular line inside the triangle from our base to the opposite vertex? Well, let's see. No, we can't. That doesn't go to the vertex. So let's see what we have to do here. Remember what I said? If the opposite vertex is not directly above the base, we can draw an imaginary line extending our base until the opposite vertex is above it. Okay, so I'm going to circle the opposite vertex again. Now you'll see we can draw our line down to our base. And in this case, we're having to use that imaginary line. So remember, when we're drawing our line, I always encourage you to start from the opposite corner or the opposite vertex and draw it down to the base. Okay? So this would give us our height. So let's look at those again. In this example, we're using our base A here at the bottom. And then we're drawing our perpendicular line to the opposite corner or the opposite vertex. So this one we can draw inside the triangle. In this example, we see our base B here. The opposite vertex or the opposite corner is here. You see circled with green. It does not fall directly above our base. So we have to draw that imaginary line out until it does fall above the base, or the imaginary line in this case of the base, and then draw our height down to the base that you see there. Then same thing with the last one. We've got our base C, the opposite corner, opposite vertex circled in green. It does not fall directly above our base C, so we have to draw that imaginary line out so we can draw our height down to the base, and that would give us our height H. Okay, so you remember I mentioned using an index card, or even you could use a ruler, whichever one you have, whichever one's easiest for you. But if we were writing these out on paper, we could use those to help us draw our height. So in this example, using an index card, again, we've got our base here. So we know we have to draw a height here from the opposite vertex down to the base. So if we're using an index card, we just lay that on the table and then we slide it across the base until we get this side of it. We slide this side of the index card along the base, and you see that arrow there. We slide it that way until we get this side of the card lined up with our opposite vertex. And you can see that example down here. So they slid the index card along the base until they reached the opposite vertex, and then they drew the parallel, or the perpendicular line from the vertex to the base. And the reason we do this is just because it makes it, instead of, you see my drawing skills are not very good. My lines are squiggly and they're not straight sometimes, like here. But if we're using that index card, it makes it easy and nice and neat to draw our height from the opposite vertex to the base. So let's look at another example. Now in this example, you notice that the opposite vertex does not fall directly above our base. So we're going to have to draw an imaginary line that you see like that. It extends our base so we can draw the line down to the base. So I'll erase that. Those are, again, see, my drawing skills are not good. And that's why if we're ever writing these out, we use an index card or a ruler to help us draw nice, neat, straight lines here. So they lined the bottom side of your index card, lined it up with the base, and then they slid it to the right along the base until it reaches and it's lined up with the opposite vertex. And you can see that in the example here. And then once we do that, you can draw your nice, straight, perpendicular line to the base, and then it ends up looking like that last example there. So line your card up with the base, slide it along the base until you reach the opposite vertex or the opposite corner, and then we draw our perpendicular line to the base to get to this last example like we want to finish up with. All right, so this last example here, we're going to draw a line segment that shows the height for our chosen base. And they already have the base chosen for us. So I'm going to go through and circle those all in red. So whichever side that word base is written next to, that is going to be the line segment that we choose to use as our base. Okay. So now I'm going to use my drawing skills again and draw a line, a red line, across the line segment that they're using as the base. Okay. Okay. Now I'm going to choose the color green. And then from here, I'm going to circle the opposite vertex or the opposite corner from our base. So it's just directly opposite of our base every time. Let's see the vertex there. This vertex here is opposite our base. This vertex here is opposite our base. And this vertex here is opposite our base. And this one. And this one. So now we can draw our perpendicular line to the opposite vertex to get our height. So in this first example, I'll go from the vertex down to the base. And we can do that really easily because the opposite vertex falls directly above the base. Same with this one. Start at the vertex and then go down to the base. Now this one, this is another reason that we use our index card or our ruler. By lining it up with the base and then moving it out until it reaches the opposite vertex, it can tell us whether we're looking at a right triangle or not, and whether that opposite vertex will actually fall directly above the base. So I think in this instance, it would not fall directly above the base. But it's hard to tell right now using the computer. But if we were to use an index card, we would see that it does not fall directly above the base. So what do? We draw our imaginary line out until it does. And then we draw our perpendicular line from the opposite vertex down to the base. All right, in this example D, if we were to use our index card, we would see that this is a right angle. So that means that from our opposite vertex down to the base, we would just use this side of the triangle for our height. So remember that anytime we have a right triangle and we choose the base opposite of the, we choose the opposite vertex directly across or directly opposite from the base, those two line segments, the base and the height, will form a 90-degree angle. So that makes it easy when we're finding our height, because that value will already be given to us more than likely. All right, so in example E, again, our opposite vertex falls outside or does not fall directly over top of our base. So we have to draw a nice parallel line or imaginary line out until it does. Then we can draw our height directly down from the opposite vertex to the base, making that 90-degree angle. All right, in this one, so you'll notice, again, if we were to use our ruler or our index card, we could probably tell that this here is a right angle, okay? But we're using our base here. if we were to draw our our height from our opposite corner to the base, giving us that parallel line, then we wouldn't be using the sides to create the right angle. So not in all right triangles that we have, we're not always going to use one of the sides of the triangle. But remember, always, once your base has been picked, or the line segment we're going to use as our base has been picked, we just draw a perpendicular line from the opposite corner back to the base, and that will give us our height. So just to go over it again and to summarize, we pick our base, then we find the opposite corner or opposite vertex, and then we draw our line, our perpendicular line from the opposite vertex down to the base to get our height. And sometimes, remember, like in example E here, once we find our base, we see that our opposite vertex does not fall directly above the base. So we have to draw that imaginary line and extend it out until we can draw our opposite vertex down to the base to get that perpendicular line. So our last slide here, what must we remember about the relationship between a base of a triangle and its corresponding height? Well, one, remember, it has to be a perpendicular line drawn from the base to the opposite vertex. Or in our case, we like to go from the opposite vertex first and then draw the line down to the base. But the line always has to create a 90-degree angle from the opposite vertex to the base. So we've got our triangle and the relationship between the base and its corresponding height. Here we say we've got our base here. So we know we're going to use this angle or this vertex or this corner to draw our height, and then we draw it down to the base. Okay. But that line that we're drawing from the opposite vertex to the base, it always has to make that 90-degree angle once it reaches the base. So what tools might help us draw a height segment? Well, we talked about using the index card, and we looked at a couple of examples on how to do that. But we also could use a ruler. And the reason we do that, again, is one, it helps us draw a nice, neat line. But it can also tell us whether the opposite vertex falls directly over top of the base. And if it does, we can draw the line inside the triangle. If it does not, we have to extend our base using that imaginary line and then draw our perpendicular line to the base. So the last question here, does it matter which side we choose as the base? So how do we decide? Well, it does not matter what side you choose. Any side of a triangle can be the base in order to find the area. However, how do we decide that? Well, it's easiest if we choose a line segment that is perfectly horizontal or goes perfectly from side to side. Or we can choose one that is perfectly vertical or goes perfectly up and down. That just makes it easier when we're drawing our line segment for our height, and it makes it less confusing when we're trying to find the area. So that's what we've got for today. I will post this video shortly as soon as it's finished uploading, and then I will put together an exit slip for you all to work on over the next few days. And let me know if you have any questions. Send me an email or a message on Google Classroom, and I will see you all on Wednesday. Have a great day.